Hi, my name is Ben Lackey. I lead the partner architecture team at Neo4j. Neo4j is the leading graph database vendor. Today we'll walk through how Neo4j thinks about graphs in the enterprise. Let's get started. Your business is agile and dynamic. Requirements are changing. Priorities are changing. New data is constantly collected and used to drive business results. You need insights from your data so you can make decisions at the speed of business. However, your data is locked in rows and columns. This prevents you from seeing the connections in your data. Joins across many tables are required to connect data and look for relationships. This becomes an intractable task as the number of hops in relational database queries increases from 3 to 5 and beyond. The result is slow query performance, impacting applications and users. To mitigate this, many man-hours are spent creating many-to-many tables to facilitate complex joins in SQL. The result is that valuable patterns remain hidden in your data. This leads to suboptimal decision-making and reduces the speed at which your business can react to an ever-changing environment. Neo4j believes that organizations can get enormous value from modeling their data like their business in a dynamic and agile way. Data usually has the right context in it. For instance, consider 5 pieces of customer data: when a customer accesses a website, clickstream data, what a person was accessing, did something get left in a cart, what did a customer search for. If this data were modeled the way it was going to be queried or used for business, it would be most natural to store and query that data as a graph. For many business problems, we start with the flow diagram, considering things like who is connected to what, how will things get used, what decisions need to be made, what criteria might be used in making those decisions. These questions are naturally graphs. Neo4j believes it is most effective to model, store, and query in the same way you are thinking about your business, as a graph. In any enterprise, we encounter 7 graphs. For instance, every business has a customer hub. This is where sales, marketing, customer service, and field service all collaborate. They have data. They acquire data to serve the customer better. Traditional solutions require SQL loading, ETL into analytics solutions, and many complex joins to connect relationships. Storing customer data with a relationship-first model simplifies your architecture. If you collect, model, and query all these graphs together, you will find that valuable patterns emerge naturally from your data. Consider a graph of customer data specifically. Once the data is modeled, stored, and queried as a graph, it is easier to make recommendations, run loyalty programs, reduce churn, price dynamically, and advertise. Another common graph is network and security. Any organization has assets such as computers, servers, printers, and other tangible things that the company owns. These assets exist in a particular location. They have access patterns. They have permissions. All these things are related and connected to each other. Storing the data in a graph unlocks improvements in identity control, reputation scoring, and threat detection. Intuit, the financial software giant, serves 100 million customers worldwide. They've built their brand on being a reliable company and being good stewards of customer data. Intuit must have a clear view of their infrastructure at all times to manage the breadth and depth of customer data within their products and take robust security measures. They were finding it challenging to perform endpoint to asset attribution. This is critical to get the comprehensive visibility needed for effective security responses to ensure sensitive information remains safe. Intuit addressed this challenge by building a knowledge graph platform to protect its network infrastructure. This ingests 20 million events into their Neo4j graph and maps out a complex web of 65 million nodes with 190 million relationships. Now they are able to calculate the risk score of every asset in the company, and they can do it in just 4 minutes. Now let's look at an employee graph. When an employee is hired, they're given a role. They have skills. They have reviews, performance scores, and learning paths. Modeling this as a graph enables better career management, recommendations based on skills, and can inform organizational structure. NASA uses a Neo4j knowledge graph to analyze relationships between employees, skills, and jobs across the organization. They needed to improve their ability to identify and manage skills within their workforce, especially in light of changing work environments such as hybrid and remote work. NASA addressed this challenge by creating a knowledge graph that combines data such as employee information, job descriptions, performance evaluations, resumes, and training records. Now NASA can quickly identify skill gaps, suggest career paths, and improve workforce planning. This has allowed NASA to better understand their employees' capabilities, improving talent management, and adapt to changing skill requirements in the space industry. The system has significantly reduced the time needed for complex queries, in some cases from 1 to 2 days to just 5 minutes, enabling faster and more informed decision-making in workforce management. Every company offers a product or service, sends out invoices, collects payments. If modeled in a graph, these become connected. This enables a variety of fraud detection. For instance, you can uncover money laundering schemes such as circular payments. Product data encompasses a variety of information into how a product is performing and how customers interact with it. Key types of data include product specifications, R&D, pricing data, and customer feedback. Dell, the global technology company, serves millions of customers worldwide with customizable products. A Dell laptop has dozens of potential configurations based on disk, RAM, and display options. Dell needed to redesign their pricing platform to handle these complex product configurations while maintaining performance. Dell addressed this challenge by using Neo4j and their pricing as a service platform. The system processes up to 50 million events per day across different regions. Now Dell can perform just-in-time price calculations for customized products, implement flexible pricing strategies without hard-coding use cases, and achieve more predictable SLAs. This has allowed Dell to decouple price authoring from calculation, giving business teams more flexibility in creating pricing campaigns and reducing time to market for new pricing strategies. Data collected and queries for supply chain management include key information such as supplier performance metrics, including on-time delivery rates, lead times, and quality control data. Inventory levels, production schedules, and demand forecasts to ensure efficient resource allocation. Cost data, including pricing agreements, shipping fees, and total cost of ownership, helping to manage expenses. Tracking data on shipping status, transportation routes, and logistics, ensuring smooth operations. Supplier compliance with contracts, sustainability practices, and certifications all play a critical role in managing supplier relationships and optimizing the supply chain. Taken together, these form a graph of a supply chain. Transport for London is responsible for running the day-to-day operations of the city's public transport network and management of their main roadways. They decided to set up a digital twin of the London transport network using the Neo4j graph database. TFL's objective was to dramatically improve the ability to detect and address incidents on London's road network in as close to real time as possible. They set up a test product which was fed data from their Neo4j graph database running on Microsoft Azure. This test product could tell them in near real time if there was a problem on the road. On the day of the test, the system detected 5 incidents that the control room didn't pick up. That was the proof they needed to go to a full implementation. That enabled TFL to cut congestion by 10%. This resulted in a savings to the city of $750 million per year and over $1,500 in time back per driver. Process optimization in an organization includes operational performance metrics such as cycle times, throughput rates, and bottleneck analysis, detailed data on resource utilization, including labor, equipment, and material efficiency, quality data such as defect rates, error logs, and rework frequency helps identify areas for improvement. Cost data related to production, waste, and downtime is crucial for streamlining operations and reducing expenses. By integrating real time monitoring data and predictive analytics, organizations can identify inefficiencies, optimize workflows, and enhance productivity across various processes. Boston Scientific faced a daunting challenge: reducing the volume of defects in a complex manufacturing process with thousands of interconnected systems. Multiple analytics teams across different countries worked simultaneously on analyzing the business's siloed data sources. These teams would spend dozens of hours waiting for queries to run, often duplicating efforts. By building a Neo4j Aura DB database to connect finished products, parts, and production issues in the cloud, Boston Scientific transformed their analytics process. Query times dropped by 83%, from 2 minutes to 10 seconds. Neo4j graph data science algorithms enabled ranking nodes based on their proximity to failures. These algorithms help Boston Scientific swiftly identify the root causes of plant defects, ensuring they can deliver the highest value to their customers and improve manufacturing processes. The 7 graphs exist within your enterprise. As we've seen, modeling individual graphs has value. At the same time, when taken together, these 7 graphs form a graph of graphs. Modeling your business this way reduces silos. This increased agility improves competitiveness. We're excited to explore how graphs can help your business. Thank you for your time.